This is a video on limiting reactants and in excess. So right now at this point in stoichiometry problems, you probably have seen a lot of these problems, right? Like you're given a chemical reaction, and if you're given a grams or a mass or anything of something, you have to calculate how much of another is produced, right? So anytime you go from one sort of reactant species to another, this is where you have to use stoich. It doesn't matter if it's going from products or reactants to products or products to products or reactants to reactants. Anytime you're going from one to another, you need the molar ratio, you need the stoich, you need the molar coefficient. So I'm missing an arrow here. So this is a general question on stoichiometry. If you want to practice this, go ahead, but we have done this in class. And if you even want to sort of fast forward this into the limiting reactants calculations, you're welcome to. But this is, once you have done this, if you calculate the mass of N2F4 produced, you'll get an answer of about 9.18. So that's stoichiometry. So far that is just very straightforward with one given. But now in limiting reactants and in excess, this is where you are given the mass or the amount of two things. So instead of just having one thing, you have now another amount of another reactant species. Basically you have the amount of both of your reactant species reacting together, and you have to decide, well, what happens now when you have 3 grams of this and 3 grams of that? Once the reaction has finished, do you have 0 grams of both of them? Like, do they go into completion? Well, to understand that, let's look at this sort of example. So this is going back to 3 grams, 3 grams. What would happen once they react? To understand what would happen, you have to, or we can start off with something like a recipe. So if we have 2 pieces of bread, 1 lettuce, and mayo, if that is my recipe, it makes a sandwich. This recipe is not going to change, right? If I have 4 pieces of bread, that means all of these ones, the molar coefficients, will be all adjusted accordingly. So then the question here is, what happens if you have 50 million pieces of lettuce, but only 7 pieces of bread? So by simple math, I'm sure that you can calculate that the amount of sandwiches that you can make is pretty much just 3 sandwiches, right? Because you can see that it doesn't matter how much of this lettuce that you have, but you only have 7 pieces of bread. So you can only make 3 sandwiches, right? You can have, here's one, like you take that, you can take another one, you can take another one. So basically that's all of the sandwiches you can make, right? 1 sandwich, 2 sandwich, 3 sandwich. Doesn't matter if you have 50 million lettuce. So what happened here is that the bread is what we call a limiting reagent or limiting reactant, because the bread will be used up first, and because it will be used up first, it determines the amount of product that we have, right? It determines. With our 7 pieces of bread, we can only make 3 sandwiches. It doesn't matter how many slices of lettuce we have. And that's it. So that's what a limiting reagent is. So a formal definition of this is this. Definition: the reagent or reactant is the one that limits the amount of products, so that determines how much products that we'll have. So if the limiting reagent, if you find the limiting reagent, that's going to be used in determining the amount of product. This reagent is completely used up, so just like your bread, it will get used up first and determines the amount of products produced. Since we're talking about stoichiometry and all of this stuff, this is only going to be measured in moles. You can't compare grams with each other because different elements have different number of grams, right? Just like your molar masses. And it's also not necessarily be the smallest mole number, so don't get this confused, because sometimes you think it's the smallest one, but it's not. And something that is in excess, this is like the opposite of limiting reagent. This is the one that you have an excessive amount, where you have too much or too many. Just like the lettuce, we have 50 million. We don't need 50 million, so we have a lot of leftovers. So the excess is basically the leftover in the reaction. Okay, so this product does not depend on the reactant because it has an excess amount of reactants, just like the lettuce. Okay, so let's try an example. In order to solve for this, here's where we start. This is the steps I use with my class, and this is the example. So I'm going to go over these steps with each of these. First step, you need to balance the reactions. So in this one, this is my reaction, and it's already balanced. And the question is asking, if you're given 50 grams of H2, 25 of O2, which one is my limiting reagent and which one is the excessive one? So let's start. Second step. we need to calculate this in moles. So I'm going to break this down. 50 grams, this is of H2 times the division bar. So grams of H2, and then we need to find moles of H2. So this is what we're going to do. That's 1 mole. Since the molar mass of H2 is going to be 2 grams, it's a pretty straightforward one. So this is just going to be 25 grams. Oh, nope, 25 moles of H2. The next one is 25 grams of O2 times division bar. So this is going to be grams. We're going to have moles of O2 at the top, O2 at the top. 1 mole, this is from the molar mass. So since we have O2, this is going to be about 32 grams of that. And I believe the answer here is 0.78125 moles of O2. So that's my second step. So once I have all the moles, it's pretty good. I'm just going to double check my calculations. The third step here is 25 divided by 32.7. Yeah, that's right. The third step is setting up the table. This is where it gets a little bit tricky. The setting up the table, you're just setting it up just to organize what you're given and what you are actually needing. And how you want to set this up, write your reactants or what you're given, like reacting species. So you have your H2, you have O2, create a little grid. And the first row that you want is, well, what exactly are you given? So this is the given amount. This is the amount of moles, so all of these ones are in moles that you're given. So since we're given 50 grams has 25 moles. So this is my 25 moles. We'll go in here. And then 25 grams of O2, this will give me 0.78. So you notice that even though 25 grams and 50 grams, they're very, very close. I mean, it's just half of it, but the amount of moles is a lot different. This is 25 moles, this is 0.78 moles. So always convert back to moles. The next row you want to have is, well, how much do you actually need? Right? How much do you actually need if you have 25 grams or 25 moles of H2? In other words, if you have 50 grams, how much of this 50 grams is going to react with the O2? Okay, so that's what we have to calculate. So how we need to do that, or what we need to do that, is that we need to use stoichiometry. So I'm just going to see if I can go and scroll down a little bit. And how we set this up is that we just have to set up for each of them. That means that if we're given 25 moles, this is all stoichiometry, 25 moles of H2 times the division bar, moles of H2, moles of O2. You need to go back into your molar ratio. So what's my molar ratio? It's 1 to 2. So this is going to be 1 to 2, right? So if I cancel all these units, I'm going to have 12.5 moles of O2. This 12.5 of O2 is the amount that I'm given, that I need. So the next point is then how much of this of O2 with the H2, 0.78125 moles of O2 times division bar. Maybe let me extend this page a little bit. So then I need your stoic, so I'm going to have moles of O2 in the bottom, moles of H2 at the top. So the ratio now is reversed, so it's 2 to 1. So then I'm going to cancel my moles of O2, and this answer, I'm just going to put it here, should be 1.5625 moles of H2. So this is where it gets a little bit confusing. Let's put this all in. So what you have to just solve is how much you need. So if you use 25 moles of H2, 12.5 of the O2 is what you need. If you use 0.78125 moles of O2, this is the amount of H2 that you need. Okay? Put this in your table because it will make it a lot simpler once you put this into table. So let's see if I can move this table a little bit so then there's more room. So the next thing I need to do is, well, understand this. If you're given 25 moles of H2 and you need only 1.56, that means that you have more than you need, right? This is extra. This is just like the lettuce where you have more of lettuce than you actually need. So if you actually subtract these two numbers, 25 subtract 1.56, you actually will get a positive number. Whereas if you take 0.78 subtract 12.5, you actually get a negative number. So this negative number will indicate that you don't have enough, so this is your limiting reactant. And this positive number because you have leftover, so this is your leftover. So this is going to be your excess. Well, there's not that much room. Okay, so that's how you determine your limiting reactant and your in excess. So going back to the steps, this is all in step 4. Calculate the number of moles needed for each reacting species. This is a very important step because, like what we just did, it is a very important step. You are going to use stoichiometry with molar ratio to calculate the other. Make sure you have all your units correct, because if you get these units mixed up, putting it into this table will get your answers mixed up as well. The last step is that we don't need it for this one, but last step is that if you're asked to calculate, say, the amount of products created. Say like if we were to switch up the question and says that, well, how much of H2O am I going to create and react if we had this amount of reactants? That's where we have to now use your limiting reactant, which is the O2 in this sense, and use this and calculate the mass. So I'm going to put that in my next example, but try to understand this table, get this table correct, know this step, step 4, this is your molar coefficient. Hopefully this video on limiting reactant is good. Try the next one so then you get a hands on the work involved. Okay, so see you later.